All right, welcome everyone to Lambda School's Mini-Bootcamp lesson number 5. You have a different instructor tonight. My name is Ben Nelson. I'm one of the co-founders and also the Chief Technical Officer of Lambda School. Dan broke his back skiing today, so he's going to be out for a couple days. But yeah, so anyway, he'll be doing okay. He isn't paralyzed or anything, thankfully. So he should actually have a fairly quick recovery time, but he is out for the time being. So send positive vibes his way. We hope that he can get better soon. All right, but yeah, I'll be jumping in and teaching you guys tonight. We'll be going over some more JavaScript. Yesterday was your first, or last weekend was your first lesson. So we're going to be covering, going a little more in depth today and reviewing some of the stuff that you guys went over last week. Yeah, it's some fun stuff. During my lecture, ask all of your questions in the Mini Code Bootcamp channel. So just drop them in there, and then I'll answer them as I go along. All right. Okay, so yeah, first I'll introduce myself a little bit. I studied computer science, university. I ended up going to coding boot camp. This was several years ago, and they were first kind of becoming a thing. Got a job as a full stack software engineer, and then ended up teaching computer science on the side. So I've been teaching and working as a software engineer for quite a while. Yeah, just Austin and I got together and we just saw that there were a lot of code boot camps out there that offered a subpar education, honestly, and there were, they were incredibly expensive. We were frustrated with the student loan crisis and the current state of higher education in that regard. And so we wanted to create an incredibly accessible but high quality education that's available to anyone regardless of their financial background. And so that's when Lambda School came to be. So Lambda School, so right now you're in our mini boot camp for our computer science course. And so that course specifically, it's 6 months long and 6 months long full-time. We teach full stack web development. So it's front-end development, back-end development. So like the server API database stuff, as well as front-end stuff with HTML, CSS, JavaScript, and then React and stuff there. We teach Python on the back-end as well as Node. We teach relational databases and non-relational databases, so SQL, NoSQL databases. And then we also teach computer science fundamentals, the kind of stuff that you get at a university. So the stuff that is not as practical, but it's foundational, and it helps you just understand how things work under the hood. And so we do stuff like computer architecture and get into the nitty gritty and how your computer actually works, and we go over C. So we learn how to program in C. We learn how the operating system, how operating systems work, and memory management, and all that good stuff. You finish off with capstone projects where you get time to work with other students to develop some different applications that you can then put on your resume. And then because our students don't pay anything until they get a job, we have a fully fleshed out support team that helps our students through their job search process. We've been able to provide a lot of our students with different contracts, things like that to help them get their foot in the door. But yeah, we do everything that we can to be able to take you from not knowing anything, which right now you're a beginner, and be able to guide you along through this process until you have the skill set necessary to be able to make a living doing this kind of stuff. And it's a lot of fun when you can reach that point. And for those of you that are here that that aren't going to be taking our course, just happy to have you here. And it's just this will be a free service that we'll be providing going forward. So we have one that's starting tonight where we're teaching some basics of machine learning. This is free, and it will always be free. And if you're interested, you can come and apply for one of our full-time courses. So let's dive in and go over some solutions to your last homework, the JavaScript 1 assignment. I'll walk you through how to run the tests and how all that stuff works and how that all fits together. So again, as you have questions during the lecture, comments, things like that, put them into the Mini Code Bootcamp channel. Okay. All right. In fact, as a little sanity check, when you get to this point, make a comment in the Mini Code Bootcamp channel. Give me like a thumbs up, like the thumbs up emoji or something like that, just so that I can get a little sanity check and make sure there's that we're all connected here. Okay. All right, let's go through and start walking through some code. Awesome. Okay, so I have about a 15-second delay, so not too bad. Okay. All right, so let's walk through some of these first problems. Okay. All right, so first thing we need to do is we need to be able to run the tests. So to run the tests, I'm going to pull up terminal. And let me zoom it in a little bit. That's pretty far out. Actually, sorry, I'm in the wrong tab. Actually, I'm in the wrong window. Sorry about that. I was working on our website actually a minute ago. That's what that was from. Okay, so clear this out. All right. So I'm inside of the main folder. So if I type in ls here, we can see here are all the different homework folders. Inside of that, anyway, I'm inside of the pre-course folder. And so I'm in the root of the folder. The root is like the top level of the folder. So in the root of the folder, I can type in npm test lesson 4. And if I type that, there's a thing inside of the package.json file that's going to go in, and it's going to interpret that command, and it's going to go through and it's going to run all these different tests that we have in here. And so we're going to see there's 28 failed tests, one failed test suite. A test suite is a collection of tests. So there's 28 failed tests in the one suite that failed. And so we can scroll up and it gives us details about all the different ones that failed. So initially, all 28 tests should fail. Of course, like they'll all fail, of course, because we haven't written any code yet. And so we scroll up to the top here, new string should be a string, etc. So anyway, here's all the failed tests. So now our job is to go through and make them all pass. Let's work on this new string one. So I'm going to jump back over to my editor. I'll zoom that in a little bit more. All right, so new string equals null. Okay, so create a string variable. It can contain anything. So I'm just going to get rid of the null. I'm just going to type in a string there. Then an important thing is I need to save the file. Right now I see this little circle here. As I save it, it turns back into an X. And then now the color of the file's changed over here, meaning that it's been modified. So make sure you save it. If you don't save it, then the test isn't going to have your changes. I'm going to come back in, run the test again. And we see that one has passed. So 27 failed, one passed. If I scroll up, I'm zoomed in pretty far, so it's quite a bit of scrolling. But anyway, so you see all these red X's. I scroll up, and here we have a green check mark. So it passes. These are called automatic tests. And most applications that you see out there, like Facebook, Amazon, stuff like that, they have thousands and thousands of different tests like this behind the scenes that test their code. And so what you'll find is that when you have a lot of people working on a lot of code, stuff can break. And so anyway, it takes a long time to or you have to be able to keep track of all the code that's stuff that's so, or like sorry, I lost my train of thought. I saw it come up. Lost my train of thought. So essentially what it means is that or why we do automatic testing is it makes it so if you change something in your code, it gives you confidence that the rest of the code base didn't just break from the change that you made. Because maybe you tweaked one little thing and it broke something on the other side of the code base and you didn't know about it. Well, automatic testing makes it so you can know that your code is still stable and working, and it allows you to instantly check to see if all the code works. And by instantly, sometimes it can take a few minutes when you get into really, really large code bases because there's lots of stuff it has to check. But Anyway, it's an absolute necessity. We teach a lot of this testing stuff and how to write good, clean code. Yeah, so anyway, this is your first interaction with testing. Later on in our full-time course, you actually learn how to write tests. But so here we're just writing a couple different types of values in for these variables. I'm going to go fast just because we're already 11 minutes in, and so I'm just going to go kind of fast for the next couple minutes. So anyway, you can always rewind if you need to. And yeah, so just a number. So this one, a Boolean variable. If you remember, that's true or false. Let's make this work. So 10 minus what equals 5. So we'll do a 5 here. 10 minus 5 will equal 5. Remember, triple equals is comparing equality. A single equal sign is doing an assignment. So right here, new bool is set to the value true. Here we're saying new subtract. We're setting it to the result of this expression. And so 10 minus 5 is 5. 5 equals 5. And so this whole thing is actually going to evaluate to the Boolean true, just like we wrote up here. So this whole thing is actually going to turn into the Boolean true. Okay. And again, the comments are ignored. So all right, so it's going here, 10 times what equals 40, so 10 times 4. 21 modulo 5 equals what? It'll be equal to 1, because the modulo gives us the remainder. I'm going to get rid of these spaces after these before those semicolons too. Okay. All right, so now let's go back and run our tests again. I'm going to press the up arrow key, and it goes to the last command that I typed, so I don't have to type it all out again. All right, so now we see 6 passed, 22 failed. Let's scroll up, make sure I don't have any typos or anything anywhere. Okay, all right, so those all work. Okay, so now in these ones, again, we have our functions here. So a function, this to review, is a little block of code that, we're running some code that we're going to be a piece of, like a block of code that we're going to be reusing. So return the string provided with the string parameter. So this is the value that's passed in, and then we can return something from the function. Okay. So these are like the input to the function, and then whatever we return is the output. So we're going to get this input, and if you remember your math from high school, functions, that's where this code concept gets its name from. Anyway, so at a high level, it's some similar concepts. Adding here, we're going to add these together. So again, I'm going to go kind of fast. So return x plus y, subtract y from x. So let's see, return x minus y, multiply x times y. And there's different ways you can write this, and it's just as valid. I mean, I could do const product is equal to x times y, and then I could return product. This works as well. We want to optimize for simplicity, make it simple to read and easy to understand. So just write whatever is easiest for you to understand at the time, right now. An important thing too is to keep your code consistent. Make sure that like your spacing and everything is all very consistent. Okay, I'm going to skip over a couple of these. If there's some that you really want me to talk about that I'm skipping over, message it out real quick. Let's see, less than 90, so I'm going to return less than 90. And what this is going to do is it's going to take our number that comes in, and then this expression right here will evaluate to either true or false. Okay, greater than 50, we'll be just doing the same thing here, but we're just going to switch that. Okay, the is even, this one's kind of tricky. So the way that we can tell if a number is even or not is we divide it by 2, and we get the remainder. So if you divide a number by 2, and 2 divides into it evenly, then it's even. If it doesn't, then it's odd. And so what we can do here is we can say return num equals 5 in here. If we take 5 modulo 2, that's going to give us the number 1. and 1 doesn't equal 0, so that's false. If we had the number 6, then 6 modulo 2 will be 0 because there's no remainder. So again, the modulo gives you the remainder. And so 0 equals 0, so that would give you true. So this right here will give us, tell us whether or not it's even. For the is odd, we just reverse that. So, or we either check to see if it's 1, or we can say it's not equal to 0. So again, the exclamation mark and the equal signs, that means not. So again, yes, this is a review. So for those of you that are asking, so I see, yeah, I'm reviewing answers from last week's homework assignment, and then I'm going to be diving into the new stuff in just a minute. Okay, so this JavaScript stuff is some of the most important stuff that we're covering in the mini bootcamp. So we'll take a little bit more time covering previous day's solutions. But, so square, cube, raised to power, some of these are using the math object. Let's do raised to power. Return f.power num exponent. The math object has this pow function on it. Kind of like you use console.log, and we pass in 2 numbers. And so this will raise it to that exponent. So if it's like 2 cubed or whatever, you know, this would be the 2, this would be the 3. Okay. So people are asking about our same length. Just make sure I passed that. No, I have passed it. Okay. Our same length. Okay. So return true if the 2 strings have the same length. Otherwise, return false. Okay. So we want to check the length here. We're going to return str1 dot length equals str2 dot. Okay. And again, if and I'm going kind of fast here, so you can go back and rewatch this. And we don't have time to go over all of these, but just trying to review some of the key concepts. So the dot length property on the string gives us the number of characters that are in it. So if we had ABC and DEF that came in, so string 1 is ABC, string 2 is DEF, then we'd come down here and we would say ABC dot length would be 3. And then str2 would be DEF, and then dot length would be 3 as well. So is 3 equal to 3? Yes, 3 is equal to 3. And so this right here, this whole expression would then evaluate to true, and the function would return the Boolean value true. Okay, add exclamation point. Let's see, with round number, those are just going to use math.round. Round up is going to use math.ceil at CEIL for sealing. There's just an exclamation point here. Okay, so we're just going to return str plus an exclamation point like this. And so you can actually add 2 strings together using the plus sign. So this is called string concatenation. It concatenates the strings. It adds them together. And so this will take an exclamation mark and add it onto the end of whatever str is. Okay. Let me do this one, return line. So return the two strings with a space separated by a space. So return first name plus, you can put a space there, plus last name. Okay, so it's the simplest way to do it. There's other ways we can do all this stuff. And when you get into our course, we teach some more advanced ways, some things to do some of this stuff that's a little better, but this is great for right now. Okay, so just separate up the space like that. So it just kind of squishes them all together into one little thing. All right, get rectangle area, turn times width. Again, if there's specific problems that you want me to go over, feel free to drop those in. I'll talk about it. So just like the width, get greeting. anyway, so the get grading is just kind of building off of those other ones. So let's run through and run some of these tests real quick. Okay, so I have 18 passed, 10 failed. So we come through here and just making sure any of the ones I went over. Fine, cool. All right. Okay, so now we're going to dive into our stuff for today. New stuff to cover. Okay. All right, so with control flow stuff from yesterday, we kind of talked about how, let me actually, what's up, sketch.io. So, all right, okay, so before we had like an if statement, which if you can think of this visually, it's like, here's the flow in our program. And an if statement is like this little switch that that can branch off our logic in either direction. It can fork to the left or to the right. So an if statement is like a fork in the road, saying we can branch off in multiple different directions. So a for loop is something we're going to learn about today. What a for loop is we're going to get to a point in time, and a for loop is where we're going to say, all right, we want to repeat this piece of code 50 times before we move on. Okay. So if we have a piece of code that we want to execute multiple times in a row, like let's say we want to run it 20 times in a row or 1,000 times in a row, we have this little piece of code that we want to run multiple times just immediately. That's called a loop. And we're going to learn about for loops today, which are one type of a loop. There's different styles. There's while loops and do whiles, and even there's a thing called recursion that we talk about a little bit later. That's essentially another way to do a loop, or iteration is another term for it. So you have iteration or loops. Yeah, it's just control flow. This all falls under the heading of control flow. So if statements allow us to branch around, for loops allow us to repeat a piece of code a whole bunch of times. So it's just one of the building blocks. If statements, for loops, these are in every programming language. So you learn a for loop now. This is a universal programming concept that then you can then take and apply into pretty much every other programming language that's out there. So that's why JavaScript is a good language to start learning with, because it's fairly simple in its rules, but the concepts are universal. So you learn how to write a for loop in JavaScript, and it's the same as writing a for loop in every other language. I mean, like the syntax might be slightly different, but the concept is the same. So it's anyways, that's why JavaScript is just a fantastic language to start learning with. Okay, let me just pull my lesson plan real quick. Okay. All right. So, before we get into this, a couple things I just want to review real quick. So some different data types that we have. So one of the data types that we have, so there's undefined. So if I say let x, so notice how I didn't assign it to anything. I didn't assign any value to it. I run it and we get undefined that prints out. So undefined is actually it's actually a value, and so undefined is the default value that a variable has. So if we try to, so if a variable doesn't have, if it hasn't been assigned to anything yet, it's going to be undefined. Okay. Another one is, so undefined is when we haven't set anything to it yet. If we have something like let name is equal to Ben, say that later, we want to get rid of it or whatever, we can set it to null. So null is when we're kind of erasing a value. This will make a little bit more sense later on when we get into objects and future lessons. But null is a value that we have assigned, which means that we are, overriding it. We don't want that value in our code anymore. We don't want the string ben in our code anymore. Okay. So anyway, so null and undefined. Okay, so with our if statements, so the main logic in the if statement essentially we have these parentheses right here, and we're going to put some type of a value in between these parentheses. And if the value is true, then the first block is executed. If it's false, the second block is executed. So this is where that forking is coming. So if this is true, then we go down the left path. If it's false, then we go down the right path. Okay. So inside of here, so if I put the Boolean value true, see true prints out in the console. So I run the code, and we see the console.log true. It prints out. You see the string true print out in the console over there. I put false, we get false that prints out over here. Okay. So there's a truthiness or a falsiness inherent in every value that we have in JavaScript. So some values, so like what happens if we don't put true or false inside of the parentheses here? So the program will try to make sense of it. It'll try to make sense of whatever value we put in the parentheses. So if I put the number 1 in here, the 1 is going to be interpreted to be a true value. If I put a 0 in here, it's interpreted to be a false value. If I put null in here, which is what we just talked about, it's going to be a false value. If I put undefined in here, it's going to be false. If I put string in here, it's going to be true. If it's an empty string, it's going to be false. Okay, so some values will fall on the truth side and some values fall on the false side. We refer to this as truthiness and falsiness. And so if you look at the if you look in the homework and the README, some of the different values that come to be true, it talks about them. There's more details about this, but essentially true 1, a string with anything in it, arrays and objects and functions, and you learn more about that later. And then false, 0, undefined, null, empty string, those are falsy values. Okay. Some other things that I want to talk about in here are some comparison operators. Okay, and this is all leading up to the loops and the iteration stuff that I mentioned earlier. So to be able to write loops, we have to understand some of this conditional stuff that's building off of what we talked about before. So if we want to do okay, let's go in and talk about some of our like greater than or less than signs. So, and again, if you want to kind of follow along too with some of the lesson material, if you look at the README in the main assignment, it talks through in more detail all these different things that I'm touching on. So, again, that's a fantastic resource for you to look at as you're working through the homework. Okay. All right, 1 second. So now let's do, so let's talk about some like less than or greater than, or like less than greater than stuff. So 3 is less than 5. So this expression will be evaluated to true or false. So 3 is less than 5, that's true. So true prints out. Is 13 less than 5? No, it's false. Okay. But is 13 greater than 5? That's true. Okay. So you can see how, anyway, just less than or greater than, it's using for just number comparison. Okay, we can also do greater than or equal to. So 13 is greater than or equal to 5. 5 is also greater than or equal to 5. If I get rid of the equal sign, we get false. So again, greater than or equal to or less than or equals to. It's pretty much every mathematical operation that you went through in school, you can represent that in programming, represent that in your code very, very simply. Some of the, like if you're getting into calculus and stuff like that, some of that stuff will be more difficult to try to emulate. But just all of your basic stuff that you learned about in middle school and junior high is all pretty straightforward to represent in code. Okay, all right, let's talk about just equality. So we have 3 equal signs. If 5 equals 5, that's true. Does 5 equals 6? No, it does not. That is false. So the triple equals checks for them to be exactly equal. So does 6 or does the 6 equal the string 6? False. They're not the same. Okay, so there's a double equal sign, and it will try to convert them into the same type before it checks the equality. So the string gets turned into it's either the number gets turned into a string or the string gets turned into a number. But just general rule of thumb is never use the double equal sign in JavaScript. So in JavaScript, we always just use the triple equal sign, and that's a widely agreed upon standard that it was actually kind of a mistake to even have the double equal sign and what it does in JavaScript. And so nobody really uses the double equal sign. Like the vast majority of companies using JavaScript in their standards that their engineers have to adhere to, they forbid the use of the double equal sign. So anyway, it's the rules they're unpredictable and kind of convoluted around it. So triple equals. So just use the triple equals. Don't ever use the double equals. Okay. So this is false right here because the number 6 is not equal to the string 6. Okay, we can also check for does not equals. So does 6, is it not equal to 6? Yes, so that's true. So this right here is the not, that kind of flips it, the exclamation mark, or exclamation mark sometimes called a not. So we can also do something like this. We can do not null, which is true. Remember, null by itself is a falsy value. But we put an exclamation mark in front of it, and it flips it to be true. Okay, so it's like the opposite. So it's like we're taking the opposite of false, so true. If we knock this exclamation mark off, we get false. Okay. All right. Oh yeah. So ABC, is that equal to ABC? False. Okay, so they have to be exactly the same. All right. Okay, so again, it walks through all this. Okay, so I'm going to talk through some more. Let's see, actually, okay, someone's asking, can you const 6 equals string? The rule and run function will be true. Let's see. Let's see, I'm not entirely sure I understand that question, but I can follow up with you or have a TA dive into that into a little bit more in depth. Okay, so something we can do here. So again, now what we're seeing here is that these expressions are all getting evaluated into true or false statements. And so let's get into it a little more in depth here. So something I can do here. This one. I could do like a mathematical operation. So let's say 5 times 5 equals 25. Okay. So this right here is going to be evaluated from left to right. So the 5 and the 5 will be multiplied before it does the equality check. So 5 and 5 will be multiplied to 25, and then it will check to see is 25 equal to 25, and we get true. true right there. So ignore this little undefined thing right here. That's just something that Replit is doing here. So just ignore that part. This is the part we care about. Okay, so we see here that it goes from left to right. If it went right to left, we would see 5 equals to 25, which is false. So anyway, it reads from left to right. Follows the standard order of operations that you're used to in your math class. So 25 equals 25, true. It prints out. Okay. All right. So then you can get more complex and throw in larger statements, and you can do parentheses. So you could do like 3 plus 4 times 5 equals, let's see, 35. Let's see if that turned that right. If I did that right. True. Yep. So the parentheses gets evaluated first. So we have 7 times 5. 7 times 5. And actually, let's check this real quick. Actually, I'm curious if this will be 35 or not. So we run that. False. Okay. So it actually just evaluates from left to right. So here it actually ignores the order of operations. Then we'll actually just go from left to right. So it's a little bit different than how you would evaluate it in your math class. So the rules are slightly different. So just be aware of that. I'm not going to dive into all the nuances of the differences in behavior there, but just be aware that just be aware that there are some differences. Okay. All right. So again, okay. So with our if statement, we can also chain in multiple else if operations, or multiple else if checks like that. Okay. So we can have block 3 to block 1. Okay. So something we can do here, let's define a variable up on the top. Say const x is equal to 5. Okay. So now what we'll do here is we'll say if x is equal to 0, else if x is less than 0, else if x is greater than 1. Okay, we'll leave kind of a hole there. So if it's 1, it would get caught down here. Okay, so I guess semicolon there. Okay, so essentially what this allows us to do is it allows us to so essentially what this allows us to do is that as we're going through, it's we check the first condition and then check the second, check the third, etc. And so we can have multiple conditions off of a value. And so we see here that x equals 5 causes the third one, the third one to run. If I make x equal to 1, it passes through all the different checks and makes it to the end. If I make it a 0, then block 1 runs. And you'll notice that if the first block runs, none of the other blocks are executed. Okay. And so only the first check actually happens. And so it's just going to keep going check by check until it finds the one that's true. And if they're all false, it just keeps going until it gets to the else, and then it runs the else block. Okay. This allows us to chain it all together. And so so these chain together if statements here, this is one of the core things as part of control, that's part of control flow in JavaScript. So this allows us to create different kind of a funny example. Let me turn this into something that's a little bit more real. Let's see. Sona's saying math class rule dictates multiplication. Yeah, yep, PEMDAS, yep. Yeah, so the order of operations is sometimes behaves a little bit differently in coding. So Yeah, Frank just posted a good link operator precedence. So anyway, so behaves a little bit differently. But okay, so let's redo this. Let's say const name is equal to Ben. If there's no name, name has no value. Error, name has no value. Else if, I'll say name dot, let's see, name dot length is less than 3, 2, say log error, name is too short. These are funny rules. You wouldn't restrict someone's name on a website, but just anyway, just a little bit of a contrived example, but it's showing how this is a little more real than just checking to see like what number x is equal to. And here we'll say const.log. And maybe you'd be doing something like this, like with an email, or at least like high level, the same concept you'd be applying. It's just something like, like an email or like their password to see if it's, satisfying all the different requirements you have. Here we see so log name works, redefinition of name. Okay, see name works. I'm not sure why it's saying that. I think it's an issue with Replit. Okay, so name works. All right, so if the name was A, see error, name is too short. If there wasn't a name, name has no value. Or if this was full, I guess that one works. But so that's interesting. Yeah, it's false, true. So anyway, that shouldn't work. Something's going wrong here. Okay. All right. Let's see. Sorry, I think something's wrong with Replit. That should not be working. Sometimes in these browser-based error name has no value. There you go. So sometimes in these online code editors, sometimes it gets a little funny, and it's like in the state management. So something's like off in here, and so let's see. Okay, if I do Command Shift R, no, I don't know what's going on there. So there's some kind of issue in it. So anyway, so if you're coding locally, you'll never have problems like that. But sometimes with like a Replit or JSPen or something like that, sometimes they can get into like a little funky of a state, which could cause you a really big headache. So coding locally on your editor and actually working through the assignments, you'll never have an issue like that. But sometimes in these online services, you run into weird little errors. So, okay. All right. So now something I want to talk about. So let's say right here, we have these two conditions to check here, for the name. Let's say we wanted to combine them, or check for multiple things instead of an if block. Something we could do here is we could say, if there's no name and name.length is less than 2, and we can actually get rid of this whole thing. We can say error, we could say like invalid name. So run this, length of null. Yes, that actually like does create a full error. So here error invalid name, so what's happening here with the double ampersand? What the double ampersand is doing is that we're checking to see if both sides evaluate to true. Okay. So let me simplify this down a little bit. So if true and true, log true, else console.log false. Okay. So the two ampersands, we pronounce this and. So this is the and operator. So both sides have to be true. If both sides are true, then the entire expression evaluates the true. So if we run this, we see that true prints out because the first block was executed. If one of them is false, the entire expression evaluates to false. If both of them are false, the entire expression evaluates to false. Okay, you see it keeps printing out as false. And in fact, this is actually one of the, at a very, very low level, you have logical operators like this that are actually built into the hardware of the computer. And this is actually what the entire computer is built off of. This and operator, and we'll learn about the or operator and the not operator and some things like that. And those actually combined together lead to everything that you see on your computer. Everything is combined with these, all the logic that the computer is able to do, all these fancy complex things, all build off of these very basic and or operators, and ultimately the NAND operator, which learn about on another day. But anyway, if you're interested in learning more about that, you can Google like NAND gate or gate, etc. So that's actually some hardware components that allow computers to even work and do their thing. Okay, that was a very, very, very high level introduction, but there's actually some pretty cool stuff that we're getting into. So, all right, so we have the AND operator. The next one that we're going to talk about, our AND operator. The next one is called the OR operator. These two vertical pipes. Okay, so this is the key that's should be around by your enter key, depending on how your keyboard is laid out. So below your backspace or above the enter key, return key. So what the OR operator says is the entire expression will be true as long as one of the items is true. So they both don't have to be true. So false and true, false or true evaluates the true. True or false evaluates the true. True or true evaluates the true. But if they're both false, then the entire thing is false. So it's different in that regard from the AND operator. So again, the AND operator, both sides have to be true. With the OR operator, only one side has to end up being true. And then the final one again is the not operator, where we reverse things. So that allows you to flip it, but that kind of goes hand in hand with these other operators. So okay, now let's move this from an example. It's a little more concrete. Okay, so let's do const email is ben@com. All right, what we'll do here is if what we'll do is we'll say if email is falsy or email dot length is and 1 or equal to 0. So we'll say console.log that email. Okay. All right, so if the email is faulty, right now I have a string in here, so it's fine. So let me come up with that instead of an else block. Email is fine. Okay, but if I come down here, I get an empty string, we run it, we see error, bad email. Or if this was null, we get error, bad email. Okay. So it checks for one of those different those different conditions. Now, an email check and like a real email check is obviously much more sophisticated than this because you have to check the different characters and do different things like that. But this is just showing you the idea of, how we chain these different logical operations together and, and a potential use case for this. Right here, we're using a logical operator to do two different checks on our string. And, and then we have an error message that we're displaying saying the email isn't formatted. So, maybe on your website, when the user types in their email to create a sign up for an application, you'll have an if statement like this that's checking to see if their email is formatted correctly. And if it's not, then you're going to display an error to the user. Probably not logging it out to the console, but you'll actually be, changing some stuff in the interface and changing the HTML and CSS, and which is stuff that we talk about later on in the course. Okay. All right. So hang in there. There's a lot of stuff. I know we're moving fast, but you have this recording that you can come back and watch. There's some good homework you can go through. We have TAs that are available to help answer questions in Slack. We want to help. It is a lot, and it just takes a lot of practice. There's no substitute for just the volume of hours that you can put in on this. It takes a lot of time to really master this material. And we have 3 weeks that we teach this class, and it's still we still have to move pretty fast to cover all the material that's in here. So I know many of you you're not going to have this mastered on a first pass. You're going to need to practice it a lot. You'll need to ask a lot of questions. So so just be aggressive and take advantage of the resources that we're providing, and that's how you learn this. Especially, if you're preparing for one of our full-time classes, please be very aggressive in asking questions, and make sure that you're putting your time in on this so that we can get you to the, place that you need to be before the start date of class. Okay. All right. So let's now go into for loops. Okay. And again, there's a lot of good resources in the READMEs that you can look at that covers, it goes into a lot of these different concepts in depth. Okay, all right, let's dive into our for loops now. Okay, so now I've kind of covered a lot of the major pieces that we needed to understand in order to get into for loops. Okay. So we talked about all these different logical operators and different ways to compose if statements, for our branching logic, going left to right. So this is for like an if statement. So I'm doing that with touchpad. I don't have my drawing pad up. So for an if statement, we have all these little branching, paths that we can go down, and you can diagram out everything that you're doing in your code. And then we have our loop that's going to allow us to repeat a piece of code a whole bunch of, many different times. So someone's asking for a link. Yeah, I think Frank beat me to it. I'll post the code in there too. So you can see that. Okay. All right, so let's go. All right, walk through a for loop. Okay, so I'm just going to write it out, get it out on the page. I'm going to run a console log a bunch of times using a for loop, and then I'll walk through and then dissect the different parts. And show you how to do it. So for let I get 0, I less than 10, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this ran 10 times. So this right here is a for loop. So the for loop, again, it will execute this block of code as many times as I specify using the rules that are written up here. So again, a for loop is how we run a piece of code over and over and over again. There's some different use cases for this. Loops are super, super, super common. You're doing them a lot, especially when we get into arrays, which you'll learn about later, it's a data structure in JavaScript that we use to hold data. We use arrays a lot with for loops. But yeah, so a for loop allows us to repeat a bunch of code. So we print that out. Okay, so let's break this down. Let's break down our for loop. Okay, so all right, so the first thing we have is the for keyword. So if we look at an if statement, so with an if statement, we have this, you have the if keyword. Here we're using the for keyword. And we have parentheses, and then we have a curly brace block. So they're actually exactly the same. The way that we write the stuff in here is different, but you can see that just high level, they're the same. We just use a different keyword. So if, and then parentheses, and then curly braces. Here we have for, parentheses, and then curly braces. Now the stuff that we write in the parentheses here has a little more of a structured format for a for loop, but essentially at the high level, syntactically, they're written the same. Okay. So now inside of the for part, we're going to have 3 sections. Okay, so you have 3 sections that are separated by 2 semicolons. Okay, so here's the first semicolon, and here's the second semicolon. So you have 3 parts. We have part 1, part 2, and part 3. And with those 3 sections, we control how many times the for loop is going to execute. Okay, so the first section right here is where we can define a counter. So define a counter. Okay, so that's the first thing that we're going to do inside of this first section. This little comment I put in line. So right here, we're going to define a counter or counter. Okay, so we're creating a variable called I, setting it equal to 0, and this is the one we're going to use to keep track of how many times we've looped, how many times we've iterated or gone in a circle. Okay, the second one, this middle part, is it's an expression that will evaluate, and as long as it's true, this gets evaluated over and over again. After every loop, it's going to get evaluated, and as long as it's true, the loop's going to run. So, or it's going to get evaluated before each cycle of the loop, and as long as it's true, the loop runs. So we have our truth check, or different ways you could write that. Yeah, conditional expression. But yeah, we're just gonna, as long as this is true, we keep going. And then here, let's see, move towards false. So what this right here is going to do is this is going to modify our counter and move us closer to a condition where this becomes false. Because at some point we want this to be false. Because if it never becomes false, then the loop just goes forever. That's called an infinite loop. When you get into an infinite loop, your program crashes because the for loop just goes and it runs, and it's running thousands of times a second, and then it crashes your entire well, hundreds of times a second, but it'll crash the browser and crash your whole program. So, yeah. So anyway, so we have to move towards a point where this is false. So, so again, the 3 parts here are counter variable. Conventionally, like the convention is that we call this I, so the variable I. So let I equal 0. And then while I is less than 10, we'll keep going. And then we're going to go I plus plus. So we're going to increment I. And so what the plus plus does is it takes I and it increases it by 1. And so at each cycle of the loop, it's going to make it's going to increase it by 1. Okay. So I've kind of seen that broken down a little bit. Let's walk through this one now. Okay, I'm going to print. So think for a second about what we're going to see here. Okay. So y is going to start at 0. I less than 3, I plus plus. All right, so what we should see here is we should see 0 and 1 and 2 print out. So what happens is I starts at 0. And then we check, all right, is I less than 3? So is 0 less than 3? Yes. All right, so we're going to run through. We're going to print out 0, and then we're going to go I++. Then it'll become a 1. Or the plus actually happens before the console log, but the 0 doesn't actually become a 1 until this whole block finishes. So then it becomes a 1, and then we come back up here. So let me actually kind of make a comment here. So I is equal to 0 at first. So we come in, 0 less than 3, true. Then we're going to go plus plus, but that plus plus won't actually happen until this block is finished. So we do console.log I, so we print out 0. Okay, and this finishes. I becomes a 1. Now we come back up. All right, is 1 less than 3? Yes, it is. So we're going to go plus plus, but it doesn't quite happen yet. We come down and we print 1. We finish, jump back up. I is now 2. Okay, is 2 less than 3? Yes, it is. So then we come down, we increment it, but the incrementation doesn't quite happen at this point in time. We print out 2, we come down, now it's incremented. So we come up here and I is 3. So now we say, all right, is 3 less than 3? No, that is false. They are equal to each other. They are not less than, like 3 is not less than 3. So it breaks, the loop finishes. So if I actually console.log I here, well, that's part of the scoping thing with the I. If I define I up here, then we're going to see that I is actually 3. Because that's the point that it broke the for loop. Okay, and you can get creative in here. We could count down from 10 to 0 and reverse and switch some of these. The opposite of plus plus is you have a minus minus you can do. Let me actually walk through a plus plus example real quick. Let x equal to 5, x plus plus, x plus plus, x plus plus, x minus minus, log x, and we'll see here that it's 7 because it went 6, 7, 8, and then back to 7, printed it out. Okay, so plus like incrementing by 1 and decrementing by 1 are just super common operations in programming, and so that's when there's a little shorthand operator. Okay, so we got our for loop. I'll do let I is equal to 1, I is less than or 3, I plus plus. So here, we break this down. So the first time we come through, I is set to 1. All right, is 1 less than or equal to 3? It is. Increment, we print out a 1. Then the 1 is incremented. So then I becomes 2. So is 2 less than or equal to 3? Yes. Increment doesn't quite increment at that point in time yet, though. Print out 2, come back up. All right, it's now a 3. Is 3 less than or equal to 3? It is. We run down print. It becomes a 4. We come back up. All right, is 4 less than or equal to 3? No. So then it breaks. And so then what we'll see here is 1, 2, 3, print out. Okay. So these are the basics of for loops. Okay. So you want to be careful again. If I is at 1 and then I less than or equal to 3, just put it 300. They're really big. It's going to go all the way to 300. If I do 30,000 and run that, and it freezes for a second, and you see it all like printing out here on the right. But anyway, as I scroll down, but that kind of slows it down on Replit too. So it's actually like not even. This wouldn't really slow it down in the browser, but like with JS, there's so much stuff going on like on top that it can kind of slow it down a little bit. Because it has to like render HTML for everything that's printing over here in the console. But if we did, is I greater than or equal to 0. So this condition right here, if I is equal to 1, I greater than or equal to 0, I plus plus. As you see, we're going to be moving away from 0. Like, so I will always be greater than or equal to 0 because it's going to keep, we're going to keep increasing, and and I will get to 100 million and it's still greater than or equal to 0, and it's going to go up to 100 million and 1, and it's just going to keep going. And so this right here, if I ran this would crash my browser, and I'd have to quit Chrome, and that might kill the live stream, so I'm not going to actually do that. But anyway, so you have to watch out for infinite loops. Little piece of trivia: if you were to go tour the Apple campus, the road around their campus is called Infinite Loop. Anyway, so yeah, infinite loops. Gotta watch out for that. All right, fun programming stuff, some fun coding stuff. All right, so logical operators, control flow with if statements and else if. We learned about some different comparison operators like greater than or equal to, greater than, less than, etc. We learned about truthiness and falsiness, so the different values that are true and false. Yeah, so there's a bunch of new fun coding challenges to work through for today's assignment. And yeah, as you work through them and as you have questions, reach out and ask for help. Then we'll we have TAs on hand and instructors that will be able to come in and take a look. So the most successful students that we see are the ones who are able to. It's more about effort. Even the natural talent, and it's more about figuring out how to learn. And being aggressive with asking questions, not being afraid to look dumb. It's asking lots of questions, and it's trying to learn, for the sake of learning. Not doing things because they're required or doing things because you're supposed to, but doing things because you're curious about the subject and because you want to learn. And the more passion you can find in this topic, the easier it will be to learn. And again, you are not going to have mastery of these concepts today or tonight, especially if this is just totally new to you. This is a lot to throw at you, if you're a new learner. And this may seem really intimidating, and that's fine. Just hang in there, just do your best. It's an analogy I like to use is it's like when you're playing a sport. It's like if we're playing basketball, or like let's use basketball for example. So the for loop is kind of like I just taught you how to shoot a jump shot, and you're going to have to practice that jump shot a whole bunch, and I just explained all the mechanics of it, and and taught you how to do it, but you're not going to have it mastered now. You're going to have to go and practice it and do it a whole bunch before you can start to get good at it. That's how it is with the stuff that we taught you today. It's not this binary like check. I know for loops now. It's more of like a sliding scale. And you have to practice it a bunch to become comfortable with the ideas of iteration and looping. And as you get better at it, you become more comfortable with the basics. And after many, many hours of study and investing a lot of time into it, then you reach a point where you're good enough to be compensated and to be paid for your work, and be able to be able to build the meaningful and really powerful and applications that are out there, and do some cool stuff. So it takes a lot of time, it takes a lot of practice, a lot of hard work. So just hang in there. Anyone can learn this stuff. It's just like anything else that you've learned in school. It just takes time and and good mentors and knowing where to go for help and where to go to learn. And but this is accessible to anyone. Yeah, so for any of you that are interested, Lambda School, we offer full-time courses where we teach, web development and computer science. We have an upcoming iOS development course and an Android development course for making native mobile apps for iPhones and Android phones. You have to have a bit more of a stronger math and programming background to do those courses, just because it's a little more complicated. Like you have to know some calculus and stuff like that to be able to take those courses. A little more math heavy. but yeah, it's anyway, we teach a lot of this stuff. It's free for all of our students until they get a job. We firmly believe that that an educational institution should be motivated by producing the best outcomes possible in its students. And we're passionate about teaching and about helping people from any background learn the skills that they need to be productive members of society and be able to change their lives and provide for their families and do all that great stuff. So we'd love to have you guys come and apply and come check out our course. If you have any questions about what we're doing, feel free to direct message me or any of the TAs or other instructors or staff members in Slack. But yeah, it's anyone with a little blue check mark, white check mark on a blue background that's next to their name on Slack. So glad you guys can be here. Our next class starts the first Monday of next month. And anyone who's in here doing the mini boot camp, this also doubles as our pre-course work. So everything that we cover in here is prerequisite to being able to start in our full class. So this is the stuff that you have to know to be able to actually attend. So anyway, so feel free to reach out with any questions that you have. All right. Thanks, everyone. Take care and have a wonderful evening.